Alright, so here's where we're at with this transistor breadboard computer. We've basically taken all the components, cleaned them up, built some tri-state buffers so we can connect everything to a central data bus and make it operate more like an actual computer. So, what we got right now is we have our central data bus, which is these rows right back in here. We have an input which feeds directly to the central data bus, which is right here. It also has some control signals that are output to all the different registers and components in the computer. We have an A and B register, which are connected to the data bus. They only read information from the data bus, and they are there and there. They feed into the ALU. There's a 2's complement circuit which determines if we're doing the 2's complement for addition or subtraction, but the A and B register only feed into our ALU. And then the ALU takes the output and it points to an accumulator, which is just our special purpose register for now to handle that. The accumulator has a tri-state buffer between it, and the buffer, when enabled, will allow the accumulator to output back to the data bus. So we could basically take a value, put it in A and B, do some addition or subtraction on it, store it to the accumulator, and then we could put it back in the A or B register if we wanted to, or we could put it in the output register and output it here. So I gotta clear the output register, so clear that, there we go. So, and then there's some other stuff over here we haven't built yet that's kind of being built. So, what we're going to do is we are going to take a program and we're going to load 1 into the A register, load 0 into the B register. We're going to take the sum of A and B and put it in the B register. Remember, when we put something in the A and B register, it's automatically fed into the ALU, and the ALU will show up on these LEDs right here. However, it won't output anything until we actually enable the accumulator to read from the ALU. When we enable the accumulator to read from the ALU, we can then take what's in the accumulator and we can put it into the B register. So if I wanted to do what's in register A plus what's in register B and put it into register B, I load my value into A, load it into B. It automatically is pointing here. When I enable the accumulator to read that summation, I can enable the accumulator to output via this buffer, and I can enable the B register to read, and I will store the result back in the B register. I can also load what's in the accumulator and put it in the output register right here, so that way we can see the result of what we just did, and we can just keep doing that. So, that being said, I will take my dip switches here, 0, 0, 0, 1, I'll put 1 in the A register, I'll turn that switch off. So I enabled the A register to read from the bus, and there we go. We have 1 in the A register, and we have 0 in the B register, and 1 plus 0 is 1. So we have 1 showing up right here where these LEDs are. Now the accumulator doesn't have 1 in it yet because we haven't told the accumulator it can read the value. So I can tell the accumulator from down here to read the value. And that's it. Now the accumulator is reading the value. And if I want to put that 1 back into the B register, I have to enable this buffer to allow the accumulator to output. And I have to enable, at the same time, the B register to read from the accumulator, or read from the bus, which is being fed to by the accumulator. So, when I do that, A will still have 1, and B will now have 1 in it, which means these lights will turn to be 2, but the accumulator will still hold the value of 1. So, we'll enable the accumulator to output, and we'll enable the B register to input. And now, as you see, we have 0, 0, 1, 0 there, which is 2, because we have 1 in the A register and 1 in the B register. I could load this 2 into the accumulator by enabling the 2 to, or enabling the accumulator to read. And then I could actually make it show up over here in my output register by enabling my accumulator to read out and my output register to read in, and we get 2 over here. Now I still have 1 in the A register and 1 in the B register. I could put this 2 into the B register by enabling the accumulator to output and the B register to read. And now I get 3, which is 1, 1. And I have 1 in the A register and 2 in the B register, which is 3 on the output of the ALU. I'll enable the accumulator to read that value, and then I'll put that value in my output register. And then I'll also put that value back in the B register. So now I have 1 in the A register and 3 in the B register, and I have 4 on the output of the bus, and I'll read that value. And then I'll output it to my output register, and I'll also output it to the B register. And I can just keep doing this over and over again, and I can count. So I can enable the accumulator to read, output it, read, output it, read, output it, etc. I can also completely just clear the A register, which A register had 1 in it, so when I clear that, we went from 7 to 6, and I can clear the B register, which has the 6 in it, and I'll clear that. And I'll clear my accumulator, which you can't really see. And my output register still has a 7 in it. So now, if I enable my output register to read from the bus and nothing's pointing to it, it will just read a 0, because there's nothing on there. And there's that. So, with that in mind, we got that. So the next step is going to be to build some RAM, which is going to be built the exact same way registers are built, more like the accumulator, because we're going to need the tri-state buffers because we have to read and write to the bus. But on top of that, once I have RAM, I need to build an instruction register to hold the instruction and build a program counter. Once I have these 3 things built, I can start to automate my control logic so I don't have to manually press all these buttons. But until then, that's where we are.